Hello, Algebra 3 Trig students. In this video, we're going to begin our chapter into looking at functions. In this first lesson, we are going to kind of define what functions are, and then look at domain and range, and look at some different applications of function notation. So first off, we have to decide or kind of define what it means to be a function. And what it means is simply that every input value in our domain has exactly one output value in our range. All right. So essentially that any value that we plug into the function only goes kind of to one place, that there's really no confusion about where it's going to be placed. And you should be familiar with that, right? We've talked about the vertical line test, simply that the x values cannot repeat, and all of those things that kind of go along with functions. Our domain is going to be the set of all inputs. Typically, when we deal with functions or we deal with stuff in math class, these are typically going to be our x values, but it really can be any variable. It's just anything that we are going to choose to put into our function. And most of the time, you would, in Algebra 1, you just simply looked at a list of ordered pairs, where you looked at a table and just simply listed the x values as your domain. In this class, it's going to get a little bit more challenging because there's certain things that can mess up a domain. So there's two main things that cause or cause issues to domain or possible domain errors, I'm going to call them. The first one is that we can never take the square root of a negative number, right? Whenever you try to do that, that's not possible, and essentially because whenever you multiply a number by itself, it's always going to have to be a positive. If it's a positive times a positive, our answer is going to be positive, or if it's a negative times a negative, our answer is still going to be positive. And the second thing that we can't do that's going to cause issues to our domain is we can't divide by zero, right? You're familiar with a fraction being undefined. So if a function it does not have a square root, or it's not possible, or there's no instance where we're ever going to divide by zero, then our domain is going to be all real numbers, or essentially negative infinity to infinity. If one of these things occur, then we have to look about how do we handle those and how do we get rid of them. So the first thing here, we look at the function 1 over x. Well, there's only one value that x cannot be, right? X cannot be 0 in this case, because if x were to be 0, we would have 1 over 0, which is no good. So what we're going to do, as I said, in a typical function that doesn't have these things, our domain is going to be negative infinity to infinity, which is in the entire number line. So in this case, we're saying we have to exclude 0 from that. So what happens is we break up this typical interval, right? If we think about a number line, it is every single number with the exception of 0, right? So we essentially have an open dot at 0. So what we're going to say then is that this left part is negative infinity to 0, and then we're going to jump from 0 to infinity. And notice in both cases I'm using parentheses because that means that that value is not part of our domain. As I jump across here to 4 over x plus 2, right, we don't want our bottom to be 0, so we're simply, okay, when would x plus 2 equal 0? Well, in this case, x cannot be negative 2, because if we were to plug in negative 2 to this function, it's going to give us 0 in our denominator, which is going to be no good. So again, our number line would look something like this. We look at negative 2, that's going to be an open dot at negative 2, and everywhere else is going to work. So now our interval is going to be negative infinity to negative 2, parentheses around both, because we can never beat negative infinity, and we can never beat negative 2. And we're going to marry that with negative 2 to infinity. All right, so now move on to the next example. F of x equals the square root of x. Again, x cannot be a negative number. It's impossible to take the square root of negative 4 and get a real answer. So essentially, x has to be positive, which means that it has to be greater than or equal to 0. So now when we go to look at our interval as our answer, right, we're going to start at 0. We're going to use a bracket because it is okay to take the square root of 0. And we are going to go to positive infinity. Again, for the next one, square root of x minus 2. Again, this part has to be greater than or equal to 0, right? We have to at least take the square root of 0. So when we solve this, we get that x is greater than or equal to 2. So now 2 becomes our starting point. I'm going to use a bracket because we have the or equal to part, and then we are going to go to infinity. So that's going to kind of conclude our intro here dealing with domain. Please go ahead and watch the next video as we then talk about range.